The question here is, how does one measure the dry density and water content of a compacted soil in the field? One of the things that you have to do as the compaction progresses is that you have to verify if the compaction has been done as intended. This task primarily involves measuring the dry density and the water content of the compacted soil. There are two types of methods, destructive and non-destructive. The destructive method is pretty straightforward. You dig a hole on the compacted soil, find the weight of the wet soil that came from the hole, volume of the hole, and water content of the soil. Once you have these quantities, you can calculate the total density by this equation and then the dry density by this equation. The measurement of the wet weight and the water content are pretty straightforward. You basically weigh the soil that came out of the hole in order to get this one right there, and then use the usual procedure to get the water content. Finding the volume is the tricky part. There are three methods that are in practice. In the first method, called the sand cone method, you basically fill the hole with sand using this glass jar cone arrangement, and from the volume of the sand that poured out of the glass jar, you can calculate the volume of the hole. In the balloon method, you are basically inflating a balloon with water, and in the oil method, instead of using sand like in the first method, you are basically using oil. The advantages of the destructive method are that usually the cost can be pretty low, although it could be pretty high as discussed below over here. Number two, it's obviously pretty straightforward. There are several disadvantages associated with this method. Number one, usually the fill material varies a little bit from the one that was used in the laboratory to establish the compaction curve. So when the material differs quite a bit, the values of the dry density and the water content cannot be interpreted properly. So in that case, you may have to repeat the compaction test in the laboratory in order to establish a new gamma d versus omega curve for the actual material that you have in the field. Obviously, this is pretty time consuming and costly. The measurement of water content is not that quick, so it takes time. Number three, the measurement of the volume of the hole by these mechanical methods are not always reliable. For example, let's say you are using the cone method, sand cone method, right? So while you are filling the hole with sand, supposing say there was a little bit of vibration that came from the construction equipment or maybe from a nearby area, right? So the vibration can densify the sand, which leads to erroneous estimates for the volume. Now on non-destructive method, the most popular method that is currently in practice is this method called nuclear method. This method uses radioactive isotopes to back calculate both dry density and the water content. These are the advantages of the method. The method is pretty quick. So you can take corrective actions if necessary right away, and also you can repeat this several times and calculate a statistical average in order to increase the reliability of the readings. As per the disadvantages, the initial cost is apparently pretty high, and also the method involves nuclear radiation, and therefore the workers must take special precautions to avoid exposure to radiation. Here's a little graphic that shows how the method works in the field.